Hi, bonjour à tous. My name is Nathalie Savoie. I'm a registered dietitian with Dairy Farmers of Canada, and I will be your moderator for today. Welcome to the first webinar organized by our team of dietitians. We're thrilled to say that we have over 1,500 registrations from coast to coast for today's webinar. A Q&A period will follow the presentation, but you can ask your questions at any time. Note that we'll try to answer as many questions as we can. Si vous le désirez, nous offrons un service de traduction simultanée. Voir le bouton à cet effet au bas de votre écran. To download the presentation, simply click the link at the bottom of your screen. Now, let me introduce Kelsey Mangano of the University of Massachusetts, Lowell. Dr. Mangano is an assistant professor and director of the Nutritional Sciences program for the Department of Biomedical and Nutritional Sciences and is also a member of the University Center for Population Health. In addition to these roles, Dr. Mangano holds an adjunct faculty appointment at the Institute for Aging Research, Hebrew Senior Life, Harvard Medical School affiliate. Dr. Mangano's research interests include aging adults, dairy, calcium, protein, dietary patterns, and the muscle-bone relationship. The title of her presentation today is Bone Health, Dairy, Calcium, and Beyond.
Good afternoon, everybody. Thank you so much for inviting me to present today. Thank you, Natalie. And I'd also like to thank all of the coordinators of the symposium and the Dairy Farmers of Canada for inviting me to speak with you today, and thank the attendees for their interest in today's session. I'd like to provide my disclosures, including my current funding support and also related previous funding support for some of the studies I'll be sharing with you today. The objectives of today's presentation are threefold. Firstly, we will identify the updated roles of dairy products on bone mass in childhood and adolescence, and also on the prevention of osteoporosis and fractures in older adults. Secondly, we will describe recent research related to dairy nutrients and their interactions on bone health outcomes. And lastly, we will briefly gain new knowledge in the emerging area of the gut-bone axis and the role of the gut microbiome on bone health. As way of brief introduction, I'd like to reorient ourselves to some bone physiology. The skeleton is ever-changing. It's a very active organ where we constantly build a new skeleton in our adult lives every 10 years. So every decade, we're actually building a brand new skeleton for ourselves. And this is done through a very complex and iterative process. This slide here is showing you a picture of bone physiology. If we dig down deep to the bone cellular level, we can actually see the phases of skeleton regeneration over time. Now, in childhood and adolescence, this process is referred to as modeling, as children are constantly building bones after time and growing their skeleton until the young adult age years. In adulthood, this process is called bone remodeling, as we are constantly breaking down bone and filling in new bone over time, yet not creating a longer or stronger skeleton. We're really maintaining the skeleton that we've reached in our childhood, which I'll discuss further in just a moment. Now, this picture is showing you a biopsy of the human iliac crust. So that's just the very top of your hip bone, and this is a biopsy of that tissue. And you might recognize on the left-hand part of the panel, we're describing the cells here, osteoclasts, which are responsible for breaking down bone. So these cells will actually travel along the surface of your bones and release acid that breaks down the bone matrix and actually forms little pockets within our bone, therefore leaving area for new bone to be filled in. If we skip over to the right of the screen, you'll probably also recognize what most commonly we refer to as the second or final part of bone formation, which includes cells known as osteoblasts. Now, these cells, are responsible for building bone into those newly formed pockets that the osteoclasts sort of ate out of our bones. And the osteoblasts are going to fill in a new matrix using minerals, collagen and other protein matrices to form new bone, and in that way we're constantly building a new skeleton every 10 years. Now, what you may be less familiar with is the center of this screen, or the biopsy, known as the reversal phase. This is a newer area of interest, where we're learning that there's actually this middle phase of bone remodeling that's extremely important to maintaining our matrix while the osteoclasts are breaking down bone and the osteoblasts are building in new bone. This reversal phase includes coupling between the osteoclasts and the osteoblasts, where there is tight coordination between these cell types. And as I mentioned, this is imperative to maintain the integrity of our skeleton during the constant modeling. There's also a canopy of bone cells that is attached to the vasculature above the bone that provides bone the opportunity to relieve nutrients and to accept nutrients into this newly formed bone matrix. This canopy is also where we interact with other inflammatory markers and other biomarkers we'll discuss throughout the presentation that may influence how often and how deeply our bones are remodeled. This slide is presenting the modeling and remodeling of bone over time. So on the x-axis, you'll see time in years by decade, and on the y-axis, you'll see the development of bone mass. So as I mentioned, in the first about 20 years of life, this is where we're attaining or accruing bone mass, where 40 to 60% of our bone mass is gained from about ages 10 to 18 years of age. Now, peak bone mass, or the highest amount of bone mass that we'll achieve in our lifetime, occurs approximately 90% of our peak bone mass has occurred at about 18 years of age, and 100% of our bone mass is really achieved at the latest by 30 years of age. Now, when we talk about achieving peak bone mass, this is imperative for preventing geriatric consequences that can occur later in life if we don't attain the highest peak bone mass that we possibly can. You can think of this as building a retirement account, for example. So before you retire, as you're working throughout your life, hopefully you're putting away as much money as possible, so then when you retire from work, you can pull from that bank account and live the wonderful life that you plan to live. Now, the same thing occurs with bone. We build our bones until about age 30 and go through a very early retirement at about age 30, where then on out, typically we cannot gain or accrue any further bone mass. After age 30, we're typically losing bone every year thereafter. So you can see that attaining your highest peak bone mass is extremely essential for preventing the dipping of losing enough bone mass over time where it would actually cause us to fracture our bones later in life due to osteoporosis. Now, what you can also see on this slide is bone is somewhat, even though we are slowly losing bone mass over time, our bones are relatively constant until about age 50, where women typically go through menopause. And this is associated with an average annual bone mass loss, of 3 to 5% just during those first few years of menopause. And thereafter, women lose 1% of their bone mass every single year. For men, this drop-off is a bit less dramatic, but also occurs in their late 60s to early 70s due to loss of testosterone. Now, if individuals didn't accrue adequate peak bone mass, and they're losing approximately 1% of their bone per year, you can see very quickly how they would drop into a period of osteoporosis, which can then lead to bone fracture. This is why we call osteoporosis a pediatric disease that can then incur geriatric consequences later in life. Now, there are numerous factors that can affect our peak bone mass, and generally we lump these into two groups: our non-modifiable risk factors and our modifiable risk factors. Non-modifiable risk factors include sex, race, and genetics. Genetics accounts for 70% of the variation in our bone mass. Modifiable risk factors are hormonal factors, nutritional status, physical activity, body weight, and composition. These four factors are typically factors that we can control throughout our lifespan and are of particular importance during childhood and adolescence in making sure we attain the highest peak bone mass that we can. And today we'll talk about the nutritional components that can affect our peak bone mass. Now, we'll also be talking about the opposite end of the spectrum, or the geriatric consequences that can incur if we do not attain the highest peak bone mass as possible and maintain these modifiable positive factors throughout our lifespan. So on this slide, I'm sure you've seen this picture many times. On the right-hand side, you'll see normal bone. Those are the pockets I was mentioning where the osteoclasts are constantly digging out bone so that new bone can be formed behind it. And this is very important to maintain structural integrity of the skeleton and to allow our bones some flexibility so that if you bump your toe on a door or fall during an athletic accident, typically you won't break your bone. On the left-hand panel, you can see what happens if bone resorption exceeds the amount of bone formation. So those pockets are becoming larger and larger and therefore making bone more fragile. And you can see that the arrow is pointing to a microfracture in the bone. These microfractures make the bone much more fragile, so therefore if you were to trip and fall from standing height to your knees, you would have an extremely high probability that you would fracture your hip just from a small stumble. Now, we should deeply care about the disease osteoporosis as it can lead to bone fracture, and I'd like to just walk you through a couple what I think are astounding predictions here of what can happen to somebody who receives a bone fracture. So of individuals who are able to walk before fracture, only 50% can walk after a hip fracture. And once someone has endured a hip fracture, there's 10 to 20% excess mortality, where 1 in 5 individuals who experience a hip fracture will die within a year of the hip fracture. So this is a disease which is near and dear to my heart that I deeply, deeply want to prevent. This disease process is prevalent, it's worldwide, and therefore the well-being of aging adults must be optimized to improve the quality of life and reduce all of our health care costs. So just as there were non-modifiable and modifiable risk factors for attaining peak bone mass, there are also several risk factors that we can tackle or keep on our radar in terms of preventing osteoporotic fracture later in life. So some of these listed here are modifiable, such as having a low body weight, current smoking status, poor health and frailty, recent falls, as recent falls is actually an indicator of increased risk of future falls, and future falls can then lead to fracture. Low physical activity, as this will impact our balance and also our muscle mass and strength, and having limited balance and muscle mass and strength will actually increase our risk for falls and fractures. And alcohol consumption, this is greater than moderate intake. So really this should say more than 2 drinks per day for women and more than 3 drinks per day for men. Above moderate consumption has actually been shown to increase a person's risk of falls and fracture. Now I've highlighted on the bottom of the slide poor diet. This is what we're here to discuss today. What types of dietary factors can we be aware of and tell our patients about in order to prevent them from incurring an osteoporotic-related fracture, and also to help our pediatric patients attain the highest peak bone mass possible. Now, when we think of diet and bone, traditionally in nutrition research, we've spoken about nutrients and how they relate to a health outcome. And that's the same thing for bone. Typically, researchers have looked at individual nutrients over time and how they're related to bone mass. More recently, dietary recommendations and dietitians and scientists are realizing that all of these nutrients interact with one another. Their absorptive abilities, digestive abilities, they're all impacted and dependent upon one another. Therefore, there's a greater focus on examining whole dietary patterns and dietary food groups and how these foods and food groups can impact health outcomes such as bone. So today I will tackle this question: how does diet interact with bone health from both of these perspectives? We'll look at individual nutrients, how they interact with one another, and again, how they are formed in foods that can then impact bone health. I'd like to cut to the chase in the beginning and just put out there what has been documented as potentially a bone-healthy diet. So when we think about discussing with our patients, what type of diet could you take in to optimize your bone health, what is the most up-to-date research on this topic? And these are the 3 nutrients that have been the most well-researched and these recommendations are from a recent consensus statement from the European Society for Clinical and Economic Aspects of Osteoporosis and Osteoarthritis, published in 2014. They recommend, due to the recent research, that optimal dietary protein intake of 1 to 1.2 grams per kilogram of body weight per day, with at least 20 to 25 grams of high-quality protein at each main meal, is required for optimal bone health. Now, this is due to the fact that having enough amino acids at each meal is required to adequately stimulate growth factors and other nutrient components directly at the bone to impact those cells, the osteoclasts and the osteoblasts, that we just looked at in great detail. The second part of the recommendation is including adequate vitamin D intake at 800 international units per day to maintain serum 25-hydroxy vitamin D levels of greater than 50 nanomoles per liter. Now, this recommendation comes about from adequate evidence that vitamin D is protective of bone and against fracture, which I'll show you briefly, and also that vitamin D is required for optimal calcium homeostasis within the body as it stimulates calcium absorption directly in the gut. Further, calcium intake of 1,000 milligrams per day alongside regular physical activity 3 to 5 times a week, combined with protein intake in close proximity to exercise, is also recommended. So you can see how these guidelines, it's not as simple as needing adequate dietary intake of nutrients X, Y, and Z. It actually has to do with a complex interaction between these nutrients, the timing of intake, and whether or not they're taken alongside physical activity, which could actually augment the vasculature and how much blood is able to connect with the osteoblast and osteoclast. Typically following physical activity, there's a surge in healthy vasculature, and this provides adequate nutrient absorption, which is particularly helpful later in life as we age and as our vasculature diminishes. So this is what is typically recommended at this time as a bone-healthy diet, and you'll see based on some further research that we could probably extend these dietary recommendations to other food groups. Now, unfortunately, although we know that calcium is the most highly researched nutrient and related to bone health, unfortunately, amidst all of our dietary recommendations and public health interventions, most Americans and Canadians still fall short of dietary calcium recommendations. You can see that according to a paper using the National Health and Nutrition Examination Survey published in 2012, 80% of adolescents aged 8 to 18 years fell short of meeting the recommended dietary allowance, which was 1,300 milligrams of calcium per day. And also you can see on this slide here, figure table 2, published in 2011, also using NHANES data, showed that across age groups, you'll see that this slide shows men on the top portion of the slide and women on the bottom portion of the slide. And as you move down the column, you're going up in age years. And across every single age group, going from the youngest to the oldest, both men and women fall short of dietary calcium recommendations, which is 1,000 milligrams in the younger age groups and 1,200 milligrams per day above age 50. And they're not just falling short by 20, 30, 40, 50 milligrams. They're actually falling short by hundreds of milligrams, which is significant. Very similar results have also been observed in the Nutrition Canada data. Now, many dietary recommendations include the consumption of 3 servings of dairy products per day, as that amount can provide most of the dietary recommended intakes of calcium for the general population. So you'll see here that Table 1 is showing essential nutrient content per 100 grams of select dairy foods. So please don't let this table fool you. Make sure that you understand that these nutrients are per 100 grams of milk, yogurt, and cheese, which is typically around 3.5 ounces of these dairy foods per day. And you'll see that the calcium content is quite high across all dairy foods, and that it varies slightly whether or not you're consuming skimmed versus full-fat dairy products. Now, for this reason, typically we recommend 3 servings of dairy products per day, as we can assume that 1 serving of dairy, which is a cup of milk or yogurt, or 1.5 ounces of cheese, is equivalent to about 250 to 300 milligrams of absorbable calcium. So if you have 3 3 servings of dairy per day, which would be equivalent to 900 milligrams of total calcium. We would then also assume that across the spattering of other things you're consuming in your diet, from greens to nuts to beans and legumes, you'd incur about another 300 milligrams of calcium in your diet, which would then help you reach the total recommended daily allowance for your daily calcium needs. Now, the reason why the current recommendations stress 3 servings a day of dairy is because of the high estimated absorbable amount of calcium that can be received from these foods. The bioavailability of calcium from dairy is very unique. And this table here is from the most recent edition of Modern Nutrition and Health and Disease. It's a textbook that the latest edition, I think, was just released about 2 years ago. And this table shows food sources of bioavailable calcium. So you'll see that calcium per serving of food varies quite a bit among products. And you might often get from your patients, as I do from my own, if I am a vegan or a vegetarian or I don't take dairy products, I know I can get enough calcium through all of my greens and through spinach and things of that nature, which is wonderful that they're eating a varied diet. But I have to make sure that I educate them on the fact that there's not enough bioavailability from those sources of calcium in their foods. So you can see here that a single serving of dairy can deliver 250 to 300 milligrams of calcium a day. And to attain an equivalent amount of that amount of calcium from food, so not just getting that amount of calcium from the food source itself, but from attaining that same amount of calcium absorbed through our intestines, would require 5 to 6 servings of dark leafy vegetables or legumes per day, or 10 to 12 servings of grains per day, just to meet 1 serving of dairy. Now, the reason why calcium is less bioavailable from beans and broccoli and dark leafy greens, for example, is because of their high phytic acid and oxalic acid content. So these components actually act as chelators in the diet, and as they're mixed in the stomach with the calcium from the food, they actually will latch onto the calcium, drag the calcium through the gut, and be excreted in the feces, thereby blocking calcium absorption from these foods. Dairy components and dairy foods do not contain these chelating components, which is part of the reason why the bioavailability of calcium from dairy is so high. The other reasoning behind that high bioavailability from dairy is still being researched and is still being examined. One other point that I just want to point out quickly is that you'll notice on this slide, dairy substitutes are not mentioned. Typically, dairy substitutes, which you might also receive questions from your clients about, they have the same amount of calcium in them as do many dairy products, and are also highly bioavailable. But you have to make sure that your patients are shaking those containers quite frequently before every single use of the product, because the sediment travels to the bottom of the containers, and therefore many people don't receive as much calcium as they're thinking they do in these dairy substitute products because they're not shaking the containers prior to every use. Now, with this comment, we're just talking about calcium, right, in the dairy substitutes. But if we move to the next slide, you'll see that beyond calcium, the composition of dairy, or its nutrient composition, is very unique compared to any other food product. So this table 1 here is showing you the bone nutrient content, again, per 100 grams, so pay attention to that estimate of size there, of selected dairy foods. And it's showing you calcium content, potassium content, phosphorus content, and protein content. The reason why this is so important is that dairy products actually provide more protein, calcium, magnesium, potassium, zinc, and phosphorus per calorie than any other food. So in other words, dairy products are a uniquely dense source of these bone-benefiting nutrients. And I have time just to dive into a few of these today and show you the most updated research on some of these nutrients and how they're related to bone health. So today I'll briefly introduce you to the most recent research related to vitamin D, magnesium, potassium, and protein, and how their interactions influence bone health. Just as a friendly reminder, this slide is showing you vitamin D recommendations. On the left side of the panel, to the left of the yellow line, you'll see recommendations for individuals aged 19 to 70 years of age. This is approximately serum levels of 25-hydroxy vitamin D between 50 and 60 nanomoles per liter. And then for dietary intakes, typically the recommendation is around 600 international units per day. Above age 70 years of age, serum levels are recommended to be between 75 and 100 nanomoles per liter, with dietary intakes of 700 to 800 international units per day. This slide is a published meta-analysis from Ferrari, published in 2009, showing a compilation of 8 different randomized controlled trials that used vitamin D supplementation. And what was unique about this meta-analysis, where they synthesized the results of these 8 randomized controlled trials, was that they actually also included compliance, meaning how much vitamin D did participants actually take compared to what they were recommended to take in over time. And you'll see here that we're looking at vitamin D in regards to specifically hip fracture. And they define a hip fracture as something that's non-traumatic and that occurs from falling from a standing height. And we're looking at relative risks on the x-axis, and you'll see anything above 1 means it's detrimental or increases risk of hip fracture, and anything below 1 means that the study showed reduced risk of hip fracture over time. So actually, overall, the pooled relative risk for all of these studies combined, all 8 RCTs, showed that there was a relative risk of 0.82, meaning that it lowered risk of hip fracture over time, and this was only with 400 international units of vitamin D every single day. So individuals in these studies had reduced hip fracture by 18% and reduced non-vertebral fracture by 20% if they were consuming more than 400 international units of vitamin D every day. Now, this slide is from the same study. However, it's showing serum vitamin D levels, 25-hydroxy-D in nanomoles per liter, across 12 randomized controlled trials. And you'll see that these trials also provided vitamin D. The triangles are studies that supplemented cholecalciferol, and the circles represent studies that provided ergocalciferol as the supplement. And overall, this study found anti-fracture efficacy increased significantly with higher received dose and higher achieved 25-hydroxy vitamin D levels. So this study isn't just showing you one relative risk over time. It's actually drawing a dotted line between all 12 trials and their relative risk, showing a significant negative slope across all of these studies, denoting reduced risk of fracture over time. Unfortunately, what I failed to include in this presentation was an even more recent study produced by the same group, a meta-analysis published in 2012, of over 4,000 participants also participating in randomized controlled trials of vitamin D. And they looked at hazard ratios of individuals with, in terms of their serum hydroxy vitamin D levels. And this most recent study found that hip fracture was reduced by 37% among individuals whose serum vitamin D levels were greater than 61 nanomoles per liter, and that was in comparison to individuals whose serum levels were below 30 nanomoles per liter. So collectively, these meta-analyses of dozens and dozens of randomized controlled trials have showed that at higher doses of supplemental vitamin D, approximately greater than 400 international units per day, it reduced non-vertebral fractures by 20% and hip fractures by 18%. Higher vitamin D dose or serum vitamin D levels do in fact lead to greater fracture reduction, as these were randomized controlled trials showing effect outcomes. However, higher doses of vitamin D still need to be explored, and that's what I have listed here on the current gaps in the literature regarding vitamin D and bone outcomes. So the safety and efficacy of higher daily doses of vitamin D in older individuals are currently being researched very adequately across numerous studies, and those results will be available to us soon. And they're currently looking to see if there are any toxicity indicators of going too high with vitamin D and whether or not that could impact other consequences of health. And also, These studies were concluded, the meta-analyses drew conclusions regardless of calcium intake, and the safety and efficacy of combinations of vitamin D and calcium on bone health still need to be further explored. And lastly, there's lack of data on premenopausal women, which, as I showed you, the importance of bone health throughout our lifespan is very important, so we shouldn't just put all of our research dollars into postmenopausal women, and need to look at this premenopausal stage to determine if we can impact bone health before that large drop-off in bone mineral density. Now, magnesium is a mineral that's also deposited into our bone tissue. An adult body contains approximately 25 grams of magnesium, with 50 to 60% present in our bones and the rest of our soft tissues. And magnesium has been shown to alter our bone health. There's two mechanistic reasonings behind this. First of all, magnesium influences bone formation via upregulation of osteoblasts. And magnesium also alters the concentration both of parathyroid hormone, which is our major regulator for calcium homeostasis, and the active form of vitamin D, which is responsible for greater absorption of calcium from the gut. So overall, magnesium can influence bone in both of these ways. Now, this is a cohort study that was conducted and published in 2014 from the Women's Health Initiative of just less than 5,000 postmenopausal women. And you'll see here that they looked at bone mineral density on the y-axis across quintiles of magnesium intake, with the light bars being the lowest intake and the black bar being the highest quintile of magnesium intake. And we're looking at three different bone sites: the hip, the spine, and the whole body bone mineral density. And you'll see at both the hip and the whole body, bone mineral density was significantly higher, specifically 3% higher at the hip in the highest quintile of magnesium intake compared to the lowest, and 2% higher whole body bone mineral density in the highest quintile of magnesium intake compared to the lowest quintile. Now, this study did mark that they did not find incidence of relative risk reduced for hip fracture nor total body fracture across the different quintiles of magnesium intake. They only saw significant association across measures of bone mineral density. There's also been randomized control trials, one of which I'm showing you here, which was also done in postmenopausal women. And they specifically looked at trabecular bone density. There's typically two compartments of bone, which I brushed over, but the inner compartment of our bone is spongy, and it's highly, highly metabolically active. This is the part of our bone that's remodeled much, much faster than the outer component of our bone, which is called cortical bone, which is much, much harder and turns over at a much slower rate. Therefore, we typically see changes in trabecular bone density due to nutrient supplements or nutrient diet changes. We see this change more dramatically in trabecular bone typically because it is more metabolically active and changes at a faster rate. So this study looked at treated individuals who were given 6 tablets of 125 milligrams magnesium hydroxide twice a day for 6 months, and then they were followed for an additional 18 months, taking only 2 of those tablets a day. And you'll see the control group was also present in the study. And compared to controls, individuals who were treated with magnesium supplementation had significantly higher mean bone mineral density after 1 year, and then their higher bone mineral density remained unchanged after 2 years, which you'll go back to the previous slides and recognize that among postmenopausal women, we would expect their bone density to be dropping by almost 1 to 2% per year just because of their postmenopausal status. So the fact that the 2 tablets of magnesium per day prevented this drop in bone density over time is also significant to note. So overall, this study showed that magnesium supplementation can be an effective preventative measure used to prevent loss of bone health over time. Now, potassium. Potassium is highly prevalent in dairy products and also across some fruits and vegetables. And you'll see that, unfortunately, for potassium, average intake is generally below recommendations. Potassium may influence bone health largely due to its alkaline properties. So higher potassium intakes have been shown to have a positive effect on the pH of our body in terms of buffering our bones and providing an alkaline environment so that if the body becomes too acidic, we typically draw calcium out of the bones as an alkaline agent to bring our pH levels back to normal. Well, this doesn't need to happen if there's enough potassium in the diet to help regulate and bathe our bone cells in an alkaline matter, and therefore we wouldn't have to leach as much calcium directly from the bones. This is evidence of potassium's positive effect on bones. I'd like to first introduce you actually to the second study listed on this side by Zhu and colleagues. This was a study done on a prospective cohort of 266 older women aged 70 to 80 years. And in this study, they measured baseline urinary potassium excretion and associated it with bone mineral density at 1 year at that same time point, and then again predicted bone mineral density 5 years later. Now, the reason why they measured urinary potassium excretion is because urinary potassium, is considered an extremely reliable and validated biomarker of potassium status, because 85% of the potassium that we consume is absorbed, and of that high percentage of absorption, 80 to 90% of potassium that we absorb is excreted in the urine, making it an extremely reliable biomarker for overall potassium status. And you'll see the results here. They found that in the highest quartile of urinary potassium excretion, these individuals have significantly higher bone mineral density both at years 1 and 5 compared to the lowest quartiles of potassium excretion. Now, to follow up with this, in 2012, a double-blind randomized control trial in 201 men and women over the age of 65, they were supplemented with 60 milliequivalents of potassium citrate or placebo daily for 2 years. And at the end of the 2 years, the potassium citrate group increased bone mineral density at the lumbar spine, specifically again with that spongy trabecular bone, and they also found this group had diminished fracture prediction scores used by the FRAX WHO prediction method. So overall, these studies show that supplementation with potassium citrate over time can protect against bone loss and possibly fracture risk over time, and potentially due to potassium's ability to bathe our cells with an alkaline substance and maintain a normal pH level. Now, dietary protein is near and dear to my heart related to bone health because this has been my area of research for over 10 years now, and I can very confidently say that dietary protein is positively associated with bone and muscle health among middle-aged and older adults. So as I mentioned, increased dietary protein can increase bone density, increase bone strength, and decrease risk of fracture through numerous outcomes which have been shown through many mechanistic studies. Briefly, dietary protein increases circulating growth hormones, which are anabolic to bone. Dietary protein directly stimulates calcium absorption in the gut, which can regulate positive calcium homeostasis, thereby improving bone health. Dietary protein directly improves synthesis of collagen and non-collagen bone matrix proteins, and also dietary protein improves muscle mass and strength, which provides anabolic stress on the bone, decreases risk of falls, and therefore improves bone mineral density and reduces risk of fracture. This was the first study done by actually my mentor out of Harvard University, Dr. Marion Hannon, who used the Framingham Osteoporosis Study to ask, can dietary protein prevent 4-year bone loss among men and women average age around 75 years of age? You'll see percent 4-year bone loss on the y-axis across quartiles of dietary protein intake at both the femoral neck, a marker of the hip, and also at the lumbar spine. And you can see that individuals with the highest protein intake on the purple bar had significantly less bone loss over 4 years compared to individuals with the lowest protein intake with the orange bars. So this is showing us that both at the femoral neck and the lumbar spine, the highest quartile of total protein intake actually prevented individuals from losing as much bone as we would expect over time, right? Because these were postmenopausal women and older men who we'd expect to be losing bone over time. So total protein in this study was shown to blunt that geriatric consequence. Now, since that time, there's been numerous other studies showing that protein is protective of increasing bone mineral density, reducing hip fracture, and also increasing bone mineral density in a randomized control trial that was done out of Tufts University. Now, there are numerous outstanding research questions in regards to how protein can impact bone health. What about the acid-containing content of diets high in animal protein? How do plant proteins impact bone health? Is it as well as animal proteins, or should we really be focusing on animal proteins? And what about these whole diet interactions that I've been alluding to throughout the presentation? This slide is the first interaction I'll show you where dietary protein has been shown to be beneficial to bone, specifically among individuals who are consuming adequate calcium intake. And this is likely due to the fact that I briefly mentioned protein actually augments calcium absorption directly in the gut. So this study was done at Tufts University. They monitored 3-year change in bone mineral density, and they looked at this across individuals who were supplemented with calcium and vitamin D compared to placebo. Then they asked, within these randomized groups, does higher protein intake protect against 3-year changes in bone mineral density? And you can see that in the calcium citrate plus vitamin D group, the highest tertile of dietary protein intake produced not only protected against bone loss over time, but actually increased bone gain across a 3-year period of time. And this was not seen in the placebo group, meaning that protein intake may be beneficial to bone only among people with adequate calcium intake. We also saw this. This is a study done out of my colleagues' group at Harvard University again, and they looked at the Framingham Osteoporosis cohort, and these were individuals with an average age of 75 years. And you'll see that we're looking at hazard ratios or risk of hip fracture over, I think it was a 14-year follow-up, across tertiles of protein intake. And if you look at the left-hand panel first, you'll see a positive relationship, which is not what we expected. Higher intakes of protein were actually increasing risk of hip fracture over time. But you'll see on the right-hand panel, protein intake was protective against hip fracture over time, and that's because we stratified individuals by total calcium intake. So among individuals with calcium greater than 800 milligrams per day, then and only then was protein protective against risk of hip fracture. So for these interactive reasons, and also due to the different amino acid profiles of protein from different foods and interaction of protein with other nutrients, it really begs the question, should we be paying particular attention to specific types of protein foods? So again, with the Framingham Osteoporosis Study, we sought to create dietary patterns specific to men and women's protein intake. And you'll see that we looked at bone mineral density across the 5 clusters of protein intake that we identified in these men and women at 3 markers at the hip and on the right-hand lower panel at the lumbar spine. And you'll see we found significant interaction with protein-centric dietary patterns in bone mineral density, particularly at the femoral neck. So I'm looking at the upper left figure here, and where the low-fat milk cluster, so individuals where the highest percentage of their total protein intake was coming from low-fat milk, they had significantly higher bone mineral density at the hip compared to red meat and processed food consumers. And although not significant, this trend was apparent across all other bone sites. And we recently also published in the younger cohort of this population as well, if you're interested in those results. So because of the interest of protein and all of these nutrients that have been shown to be protective against bone health and their interactive capabilities, very specific impact on bone mineral mass is very, very interesting, both among adolescents and adults. So very consistently, research demonstrates that among children, dairy intake is quite protective of bone health. And this figure here is showing you results from numerous studies, randomized controlled trials in adolescents that have shown that dairy intakes are protective against loss of bone over time. Specifically in children who avoided drinking cow's milk for prolonged periods, fracture risk was actually almost 3 times fold higher than in their matched birth cohort. Now, this is evidence looking at dairy intake among adults and determining, this is among children, and this is a consensus paper that was put out by the National Osteoporosis Foundation in 2014, and they determined evidence of these dairy-related studies and graded them in terms of an alphabetical scale, essentially, with grade A being the highest. And they found evidence of the relation of calcium on attaining high peak bone mass to have a grade of A, meaning that there was the highest quality research showing calcium to be protective against attaining high peak bone mass. And dairy intake was not too far behind, showing a grade of B, meaning that dairy intake, because of its unique nutrient components, is protective against bone health. Now, the story with bone health and dairy consumption in adults is a little bit more muddled, and the data aren't exactly consistent across all studies as they are typically with children. Meta-analyses generally have not shown a protective effect of milk and dairy intake in adulthood on risk of osteoporosis and bone fractures. However, these studies are limited because these have been done mostly in observational cohort studies, and we're really lacking adequate randomized controlled trials looking at dairy intakes on bone health. These are very hard to do because they can be prohibitively expensive and also require testing among individuals who currently don't consume dairy intakes, and there's a lot of nutrient interaction components that we have a hard time controlling for in these randomized controlled trials, making it difficult to assess whether dairy impacts bone health in adulthood. However, a very recent systematic review concluded in 2015 that calcium and dairy collectively are important contributors to bone health in adults. This is a recent study that, again, my group published out of Harvard University in the Journal of Nutrition in 2017, and we looked at dairy intake, not just total dairy intake across all individuals in the Framingham cohort, but we stratified by vitamin D supplement use. And you'll see on the right-hand panel what I've highlighted in red at the trochanter is that individuals with high milk, yogurt, and cheese intake had significantly less bone loss over time only if they were additionally supplemented with vitamin D, suggesting a potential interaction between vitamin D and dairy intakes and the protection of bone health. And I'd also like to lastly highlight a recent study that was just published, I think within the last month or two, looking specifically at yogurt intake among Irish adults. So in the Framingham cohort, it's very difficult to assess how yogurt intake, not just in Framingham, but in many cohorts in the U.S., whether or not it impacts bone health, because there's such little variation in yogurt intake in the U.S. Many people have zero intake. However, in Ireland, there's quite frequently high consumers of yogurt consumption. So in this cohort, they were able to identify that high yogurt intake, defined by more than one serving per day, was protective against total hip and femoral neck BMD compared to low consumers, both in men and women. And this, again, points to the fact that we really need to be asking these questions of how does dairy impact bone health in adults across individuals with very varied intakes, and then only in that way will we be able to answer those questions. I'm running out of time, so I just want to briefly run through the last few slides that are really introducing, well, why do we think that a fermented dairy product such as yogurt could have an impact on bone health? And one of the predominating questions is, can dairy overall actually impact what's known as our microbiome, or all of the bacteria that are so prominent across our bodies? So we have numerous types of bacteria all over our bodies, both on the inside and the out. And you'll see on the right-hand panel, I'm showing you all the different types of bacteria that predominate in the GI tract. And actually, the types of bacteria are quite different if you travel from the mouth all the way through to the end part of the colon. Now, aging is accompanied by something called microbial dysbiosis, where when we're born, we're essentially sterile. Throughout our lifetime, as we're exposed to environmental factors and different dietary intakes, we develop a very broad and diverse microbial system within our GI tract. However, as we age, this diverse community of gut bacteria actually diminishes. So we have reduced gut diversity in terms of the healthy bacteria in our guts, and this is known as dysbiosis. And this dysbiosis has been associated with numerous poor health outcomes, including risk of osteoporosis and fracture. So I'm ending here on a slide showing you that the gut microbiota is a proposed regulator of bone mass, and we can impact our gut microbiome in as soon as 24 hours. After we change our diet, our gut microbiome will actually change. and also use of antibiotics, other environmental factors, and pre- and probiotic use will all impact the diversity of your microbiome and the activity of your microbiome. The activity of your microbiome can actually impact how much of the micronutrients you're consuming are actually absorbed, how much calcium, vitamin D, magnesium, potassium can actually be absorbed from what you're eating. Depends upon the diversity of your microbiome. The microbiome can also influence our immune system. It regulates the gut endothelial barrier, and the thicker your mucosal and healthier the mucosal layer you have, the more protective the immune system can be of your bone health, believe it or not. And lastly, the gut microbiota, the higher diversity and the more anti-inflammatory your gut microbiota are, it could actually influence systemic inflammation, which has been shown to directly impact bone health through that vascular canopy that I mentioned very earlier on in the presentation. So that was just a very brief introduction to how the gut microbiota can impact bone health. It's an emerging area of research, and we're seeing more and more research done every year, and I hope I can come back for another webinar and discuss that with you further. So I'd like to thank and acknowledge my research team, both at the University of Massachusetts Lowell and the Institute for Aging Research at Harvard Medical School, and open up this time for any questions you may have had. Thank you so much for your attention.
Thank you, Dr. Mangano. We have a few questions on the webinar, so keep your questions coming, and we'll use all the time we have. So first of all, can you briefly review again why the calcium in dairy is more bioavailable in comparison to other calcium-rich foods like greens and nuts?
Sure, yeah, I really breezed over that rather quickly. So I think first let me look at it from the vantage point of why other food products, such as dark leafy greens, why their calcium is less bioavailable. So the calcium within these foods are less bioavailable because dark leafy greens and legumes and beans contain other products, oxalates, and also phytic acid components. These components are chelators, so they actually will bind to positively charged anions, such as calcium, which is positively charged, bind to it and not let it go in the small intestine. So if calcium is bound to another substance, it cannot be absorbed, and therefore it's excreted in the feces. Dairy now, if we look at it from the vantage point of why is dairy higher in a bioavailability, dairy does not contain a high amount of oxalates or phytic acid. Therefore, if you're not consuming a high amount of these other dietary components when you eat your dairy, you're not going to prohibit calcium from being absorbed. That's definitely known. What's currently being researched are something known as milk proteins or milk-specific peptides that have been shown to have a unique composition that can actually augment calcium absorption directly in the small intestine. Now, how this is happening, to my knowledge, is still being looked into further, but there are specific proteins that may be augmenting calcium, and those are very specific to dairy products.
What would you say to your patients that refuse or that don't consume enough dairy products?
That's a great question. So any patients who refuse dairy products, of course I don't just end there. I always ask them why. Is it the texture? Is it lack of tolerance? Just in case there are some fermented dairy products they may actually be able to tolerate due to their positive benefits on the microbiome. These products that are fermented typically have less lactose in them and are generally well tolerated compared to other non-fermented dairy products. If patients cannot tolerate dairy to any extent, I recommend fortified dairy substitutes, because calcium directly absorbed from any food component has been shown to have a more positive impact on bone health than supplements alone. So if they buy a fortified orange juice or a fortified non-dairy alternative, I always tell them, please shake the bottle as hard as you can before every single bowl of cereal or glass that you pour to make sure that the calcium that has solidified at the bottom of the canister is mixed throughout that dairy substitute component, and so that they receive the maximal amount of calcium from that fortified substance.
How would you reconcile calcium recommendations that may be different from country to country?
That's a really good question. You'll see that in the research that I've showed you, we commonly broke or stratified calcium intake by 800 milligrams per day, which is typically lower than most countries' recommendations, to my knowledge. The reason why we stratified at this point is because this was the median intake of those populations. We provided equal numbers of subjects across both groups, which is very important to have statistical power. And you'll notice that even though we stratified individuals at 800 milligrams, which is less than most countries' recommended intake, all individuals greater than 800 milligrams per day of calcium intake showed additive beneficial impacts on bone health. So although we all should strive to meet our recommended intakes, as there are little adverse events to having higher amounts of calcium intake, I think that really reaching as close as we can to those recommended intakes is important, and also keeping in mind that there is huge genetic variation among people. So really that genetic variation sort of washes out that country-to-country specific calcium recommendations as well. And I think overall just really encouraging our patients just to consume more if they're not meeting current recommendations is the most important aspect, and to maintain that visual of what can patients actually be held accountable for? What is feasible for them to accomplish, instead of really making sure that they count numbers or count milligrams? Let's think more about food groups. What can my patient reasonably accomplish? And any step forward is a step in a positive direction.
Many of the studies you described on calcium, potassium, magnesium use the supplements of the minerals. In your opinion, do you think similar results can be achieved with a healthy, varied diet? Or would you recommend that patients be put on a regimen of many supplements?
That's a great question. So I typically always recommend a varied diet and to attain these bone-benefiting nutrients through food, because unfortunately what I didn't show you were data that show that not only calcium but nutrients generally, are better absorbed from food sources. And like I said, maybe that's because of these specific milk peptides that are found in dairy. And there's so many structural components of foods that we have yet to discover that seem to be enhancing our absorption of nutrients from foods. So that is why I typically recommend that patients always receive the maximal amount of recommended nutrient intake from food products over supplements. However, I don't throw supplements out the window. So if a patient really can't do it, I do a lot of research into adequate supplementation, what's approved on the market, and what's safest for the patient.
Can you remind us what's the most up-to-date recommendation for calcium intake for adults over 50 years?
1,200 milligrams per day. And is that the same here? Yes, okay. Yes, 1,200 milligrams per day.
You talked a lot about calcium bioavailability in greens as opposed to dairy. What about the calcium bioavailability of soy beverage? Is it like tofu? Or?
Oh, okay. Yes, calcium bioavailability for soy products, it varies because soy products naturally contain phytates and oxalates, which can bind calcium and reduce bioavailability. Typically, fortified soy milk has a lower production of some of these competing chelators of calcium intake, so fortified soy milk is typically a good alternative. Tofu is particularly interesting because when a patient buys tofu, you really need to pay attention to what type of water the tofu was set in. So tofu can be set in non-mineralized water, which would not contain any calcium and therefore would not increase the amount of calcium in tofu. You'll see on the table I showed you, it specifically marked tofu set in calcium. So some tofu companies actually will set or firm up the tofu in water that's fortified with calcium, so then the tofu actually will suck up the calcium into it and become a fortified calcium product. So typically, decent, I guess, calcium bioavailability, although not quite as comparable to dairy products.
One last question, maybe. What would you say to parents who want to give their young children a milk alternative, like almond beverage, with respect to bone health and calcium?
I would say that, like I said, the same recommendations for adults, that really, if that's what the child will tolerate, and to make sure that it's fortified with calcium, and that the bottle is shaken before every use. And also that with children particularly, especially now, I think it's of particular importance not just to focus only on calcium and vitamin D, but to start to think about these other food groups that really impact bone health. So other forms of dairy that perhaps the child can tolerate. Making sure, I didn't even talk about fruits and vegetables, and the plethora of data that shows that fruit and vegetables among kids are benefiting bone health. And also making sure that they're physically active. All of these lifestyle components are going to benefit a child reaching their peak bone mass.
I'm sorry, that's all the time we have today. Thank you very much for your active participation on the webinar and for our first experience. Now, I'm pleased to announce that our next webinar will be presented on Thursday, November 16th. Dr. Dennis Savaiano will be speaking about lactose intolerance and the current state of knowledge. Be sure to mark your calendar. Thank you, Dr. Mangano, and à la prochaine, everyone.